Now we're going to take trapezoids and work their process backwards. If I'm given the area and some specific measurements, how do I find a missing piece? This is more complicated than with triangles or parallelograms or rectangles because we just have extra parts that we have to deal with in our formula. But we always start off by plugging in what we know. So we know the area of this particular trapezoid is 51. We know base 1 and base 2, those are both 7 and 10. And that divided by 2 is always going to be there. And then we're trying to find x. First, start off by simplifying. So you have to do the 7 plus 10, which is 17, and then divide that by 2, so you get 8.5. So I have 51 equals 8.5 times x, which is a lot less complicated than 7 plus 10 divided by 2. And then get x by itself by dividing both sides by 8.5. And you end up with x equals 6. Since our unit is feet, we would be feet. The process is more complicated when you have a trapezoid where you want to find one of the bases. So let's start off by plugging in what we know. 30 equals x plus 12 divided by 2, and we're multiplying by the height, which is 3. And there's a lot of different things that you can do here. You can't just multiply the 3 and the 12. Think of this fraction as kind of being in parentheses. And there's a lot of different things that you can do to solve right now. A lot of people don't like the 3 and multiply to the fraction, so you can divide both sides by 3. The 3's cancel, and you have 30 divided by 3, which is 10. So you have 10 equals x plus 12 divided by 2. And from here, again, a lot of people don't like the fraction, so you can multiply both sides by 2 to cancel out the fraction. And 2 times 10 is 20. And now just isolate the x by subtracting 12. So x would then have to equal 8. Our unit is centimeters, so 8 centimeters.